This week we're learning about systems of equations. What the heck does that mean? What is a system of equations? Well, let's just take a look at one equation. This equation we have here is y equals 2x plus 5. When we graph it, the y-intercept is at 5, and then the slope is 2. So, for example, if I were to graph this on paper, if I'm starting at 5 because the y-intercept is the starting point. Since my slope is 2, that means my rise is 2. So I go up 2 over 1, I can graph the next point. Same thing from that point. I go up 2 over 1, that's the next point. So that's one equation. That's not a system, it's just one equation. But if I graph another equation on this same graphing mechanism, let me just type a random one. Y equals 4x plus 9. So now we have a system of equations. Just a system is just two or more equations. So now we have a system. But the question is, what is the solution to the system? That's the main question you guys are going to be answering, or in what type of solution. So when we are finding a solution to a system, we're trying to figure out what one point do they cross each other? What point do the lines touch each other? And so in this case, if we look closely, we have the red line and the, I guess, black line. Um, they both are separated down here. And as they go up, they get closer and closer together until, boom, they touch each other right at this point here. That would be called the solution, where they touch each other. So if I were to be given this question on a test, it has these two equations and it says, what is the solution to this system? My answer would be negative 2 comma 1. Because when x equals negative 2, y equals 1, and they both hit that spot. No other time on the graph do those lines have the same x and y values. Down here, the y might be the same, but the x is different. Or over here, the x's might be the same, but the y's are different. But it's only at this one point right here where they actually have the same x and y values. So in writing the solution, I would write it as a point. So I would say negative 2 comma 1 as the solution. That is a type 1. That means that there is one solution to this system of equations. But there's other instances where you don't really see what the solution is just that easily. So let's say I have the equation in this new graph, y equals 1/3 x plus 6. Okay, so right now it's just one graph. But then I add another equation. Let's go with y equals 1/3 x plus 3. Still two different equations. The lines are two different lines. This is a system. But where do the lines cross each other? Let's look a little further. Let's just keep going. Do the lines ever cross each other? Do they ever touch, intersect? No, they don't. They never actually hit each other. So these two lines are parallel to each other. They never physically make any contact. There is not one x and y value where they are exactly the same. Therefore, this system has no solution. So if I were to write down what the solution is to this system, I would say no solution because there is none. They never cross ever. There's also another kind. What if I have, let's say this first one, I have y equals 1/3 x plus 6. And this next one, I have y equals 6 plus 1/3 x. What do you notice? I'm going to do that one more time. We have this first red equation. So look at the line, stare at the line. And then I write this next equation, 6 plus 1/3 x. The lines are on top of each other. This first line here, the slope is 1/3 and the y-intercept is 6. So the y-intercept is right here and the slope is 1/3. So you go up 1 over 3. But this one, the slope is also 1/3. The coefficient of x is always a slope if it's in slope-intercept form. So the slope is 1/3, but also the y-intercept is 6. So both of these equations, even though I wrote them a little differently, I did that on purpose, they both have the exact same y-intercept and the exact same slope, which means that they are directly on top of each other. Therefore, the solution to this system is infinitely many solutions, because at every single possible x value, the y values are exactly the same because they are touching each other the entire time. They never go away from each other. Both lines are directly on top of each other the entire time. So every single x value has the exact same y value for both equations. So the answer to this system of equations is just infinitely many solutions. So there you have it. We have 3 different types of solutions. The first type of a solution is when there's only one solution, where there's one value for x and one value for y, where the lines cross each other. The next one is called no solution, where the lines never actually touch. And then the last type of solution is infinitely many, where the lines touch each other the entire time. Hope this helps.